What's going on, everyone? Sneaky Mofo here, and today I'm really excited to bring you what I consider to be my first truly advanced cheat engine tutorial. I'll be taking a deep dive into a particular script that it's one of my more advanced ones. I learned a hell of a lot going through the process with this one, so I hope that I can impart some of the wisdom that I picked up into your brain. So anyway, pardon me if I cough a little bit in this video. I've got some summer allergy stuff going on, but really want to record this, so I'm going for it. Some of the specific topics I'm going to cover are like complex scripting ideas, code refactoring, advanced assembly pretty much. So we're going to step beyond like jump, move, nop, all that stuff, and into some different territory. Maybe you've seen some of these instructions before, but they're just kind of abstract to you. I'm going to be going over debugging your script with break and trace, pseudo random numbers, random number generation via assembly, bits, nibbles, bytes, decimal, hexadecimal, all that kind of stuff. So it's going to be a lot going on here. I thought about making this video multi-part, but instead of doing that, I'm just going to do it like it's a classroom lecture or something. Probably fall around 30-40 minutes. I'm going to try to keep it at that tops. So grab you a sody pop and some snacks. Stick around. You know, watch what you want now. Come back to it later. I'm hoping that it'll be a good resource for you to keep coming back to as you progress through learning some stuff about Cheat Engine. All right. Last of note, I want to mention my friend Chris Fate from Cheat the Game. His channel is really awesome. So if you're into Cheat Engine or you're just learning it or whatever, go check out his channel. He's got some good supplemental material, stuff that I haven't covered, and whatever else. So definitely go check it out. What's up, Chris? Shout outs, Holmes. Anyway, all right, so with all that said, let's go ahead and get started. I'm going to assume that if you're watching this video, you know a certain number of things. So if you're really advanced, you know your way through, you know, basically the Cheat Engine tutorial. Let's say you can make your way completely through all that, no problem. All right, that's kind of where I think you should be as a starting ground for this video. All right, but anyway. First, quick overview of the cheat, what it is, and I want to show you some things that will make the rest of the script relevant to you so you'll know what you're looking at. Okay, and I'll explain my process and show that even though I have a video on this for people to download and freely use this cheat, there's a lot that went into this. And yeah, so just going to dive right in here. I'm using Terraria, of course. The cheat is my magic bug net cheat. In Terraria, there's this thing called a magic bug net, or not a magic bug net. I create the magic bug net. It's just a bug net. It captures fireflies, butterflies, things you can use for fishing, stuff like that. All right. Well, I wanted to make it to where you could use the bug net on enemies, and not only that, but get a random item from within the game. So that presented a whole range of problems to solve to make the cheat happen. So let me just show you how the cheat works. I have it enabled. Okay, so I hit that enemy, and now I'm going to capture him with the bug net. See how it's a shotgun? I'm going to hit this one. I'm going to capture him. I'm going to do the same with this guy here. There we go. Alright, see all that stuff coming up there? That's because the item I got shows all this crap. So what was that item? Cell phone, displays everything, allows you to return home at will. That's pretty badass. I've never even heard of that. This game has so many freaking items, it's crazy. Anyway, okay, so we got these 3 random items. And I'm going to go ahead and open the cheat here. Alright, so this is the cheat refactored. Refactored means you take something that, like in this case, the case of this cheat, there are 2 AOBs that are scanned for. And when each of these were found, I was running this same bit of code in line with each of these. Now, doing the in line way with each of them, in this case, was more optimal. because doing it the way I'm doing it here with this refactoring, I'm adding in unnecessary instructions, which is essentially overhead. It's making your processor run additional instructions, right? I mean, it's inconsequential for this game and for the speed of the processor and the power of it or whatever. So, you know, when I say this isn't the most optimized, it's just technically not the most optimal thing. However, I think it's more readable, and for someone like me studying like high-level language principles and working with C# more, doing this refactoring is good practice. So anyway, what this cheat does is first off, there's two types of enemies: non-worm enemies and worm enemies. Okay, worm enemies look like worms, function sort of like worms. They're digging in the ground and they get you. Non-worm enemies are like what you saw on here, the little flying eyeball, zombies, all that stuff. So between these two types of enemies, damage is dealt to them via two different instructions, which is why I have two different AOBs here. Okay, so for each one of these, I run the AOB scan, allocate memory, do all that deal. Alright, so let's say in the case of this one, we're going to focus on non-worm enemies because these work exactly the same. Mostly. There's something I'm going to have to cover here with the worm enemies, but we're going to be able to do all of our stuff using the non-worm. Alright, so what happens is the AOB runs, right? Everything is applied here, memory is allocated, blah blah blah. The first thing that happens is EBX is pushed. I push EBX because I'm getting ready to use it, right? I'm getting ready to put something in it, so I want to preserve what's there. Alright, I load effective address, whatever is at non-worm enemy plus offset 10 into EBX. Okay, now why on earth am I doing that? I'm loading the address that's whatever here, non-worm enemy, plus 10 bytes. Okay, what that's going to do is put us here. Or I'm sorry, here. Alright. The address is going to put us here, and I'll show you why that's relevant in a second. The next thing I do, so that's load effective address. LEA, if you don't know, if I did this, if I did move, that's going to move the value that's in this dereferenced memory address. Dereferencing means taking the base plus the offset, finding what that address is, and you've dereferenced it. You figured out what the exact address is. So this would move the value from here into EBX. When I'm doing load effective address, that moves the address itself. Whatever this address is, I'm moving that address here. So first I do that. Alright, then I move that into a memory address that we've allocated memory for at the top of the script here, called return address. Alright, and the reason we're doing that is because when each of these AOBs are scanned for and replaced with the code injection, okay, they both do this. Alright, they both have the same thing to start. Then they jump to the same location. So depending on which one of these jumps to here, this has to know how to get back to where, you know, where we came to it from. So the way that I do that is at the very end of this, I have the return address, which is either here or here, except not to these exact memory addresses with these labels, memory addresses, but to the point after the jump. Because if we returned to here, we would just run this all over again, and then we're stuck in a loop. Alright, so we preserve an address, a return address, so that come back to the right place whenever our random number generator runs, and then boom, we come back to here, which once we've generated our item ID and everything, goes into the appropriate address plus offset. Alright, so that gives me a little jumping off point to break away from the script for just a second and show you that the way this works, the way this cheat works, okay, what I did was I searched for the instruction that writes to enemy health. That's what these instructions are. These are the instructions that write to enemy health. The original instruction for this one is sub EAX. So whatever, it's subtracting from its current health. Okay? And the same thing for the worm enemies. So first I found that instruction. That gave me a way to piggyback in to do my code injection. Alright. Then I did dissect data structures on a number of the NPC addresses and started digging through all these offsets that are related to the enemy. So I found one that caught my eye. Catch item. And there's 0 here. So I started playing around with this and found that if I added numbers, certain numbers in here, I could catch enemies. It made them catchable with the bug net, and I got the item number for whatever I put there. So let's first go here. I'm going to refresh this page. And these are Terraria's item IDs. So we see there's 1 through 3,800. That's how many items are in Terraria. Okay? So yeah, let me just pull this list down here. Okay, so you can see this item number corresponds to this exact item, all the way to 3,800. All right, so now that I knew that, I could kind of do this little cheat and say, okay, well, I need to find a way that whenever I attack a specific enemy, I change that offset. Which one was it? Control F, catch. Yeah, 140. So when I attack an enemy, okay, not only do I want to have its health subtracted as usual, I want a number to be added here to this offset, to this catch item offset, which will then make the enemy capturable with the bug net, and I'll get that item number that I have in there. All right? So how do I generate a number randomly? First of all, that was the first problem. Second problem, how do I keep it within the range of 1 to 3,800? Okay, so these are my two main problems. But anyway, I just wanted to show you that real quick so you could see the offset, what these mean. So, I've done the return address thing, which we've ascertained is for this jump here. Then, after all of this is ran, I have the item ID, I have the number that I want to be moved into that address plus offset. All right, which is from here moving into there. And then, restore all these registers or the values that were in these, and then the original instruction, which was subtract enemy health. All right. So now with that done, let's kind of walk through the script here. Now this is a method for debugging your script. This is a way you can change wherever you have the breakpoint specifically. And like if your script keeps crashing and you don't quite know where, you can keep moving your breakpoint up and up and up to a point where, okay, it doesn't crash when I'm on like this instruction, but it crashes when I hit this instruction or something like that. You know what I mean? So what we're going to do here is we're going to watch this whole thing work. And as we watch this work, I'm going to explain what's going on and what these things mean and all this fun stuff, okay? So, because I've enabled the script and I've registered my symbols and I've done all that, we can hop in memory view and we can just go to a specific address, one that's our label name. So, non-worm enemy. I want to go there. Non-worm enemy. Okay, so here we are at non-worm enemy, which is here. So, if I go in the game and I attack an enemy, right, it's going to, because I've enabled the script, it's going to run this, come here, and then finish it up. All right, so let's see that happen. I'm going to go ahead and here on this, I'm going to break and trace instructions. Okay. We'll say OK here. We'll say yes. OK. Now, let's go ahead and attack an enemy. Boom. Break and trace. Oh, I got to kill this fool. Okay, so break and trace. We don't have to expand all because all these are individual instructions that we are running here. So we can follow this from our script here. So push EBX, we see it here. Load effective address, this dereferenced address, into EBX, which is this instruction, and this is that dereferenced address. Okay, so when you click on the instruction, this is not, so the result of this instruction has not happened yet. Okay, so for each thing that you want to see, if I wanted to see the effects of this instruction, I need to click on the next one down, because then that means this one has executed and you can see everything over here. Okay, so we're pushing EBX. Boom. We load effective address into EBX. So let's go down here. And in EBX we see the address. See this? Boom, it's that address being moved into EBX. Then with move EBX into this address, okay, we should see, well, we're not going to see anything from that memory address because we're not looking at it. But anyway, so now we pop EBX, so whatever was in EBX is going to be placed back into EBX, and it's just all F's. So who knows what that is, whatever. Then we jump to here. So we've done all this, and now we're jumping to random number generator, which happens to be this address. Okay, boom. We've jumped there, we're pushing EAX, we're pushing ECX, we're pushing EDX, because I'm going to be using these three registers for everything I want to do. And some of these instructions have implicit things like RDTSC, read timestamp counter, stores its value as a 64-bit value using EDX, EAX. The most significant 4 bytes go into EDX, and the least significant 4 bytes, or 32 bits, are stored in EAX. Okay, so because here with this move, I am putting 3800, which is the highest possible item ID number in Terraria, I'm putting that into ECX. So between these two instructions, I've ascertained that I'm going to be using EAX, EDX, and ECX, right? So I push those three so that we preserve their original state. All right, move that value into ECX. So whenever I go down to RT or RDTSC, you will see that ECX will have this value in it. Boom. Okay. RDTSC. That's going to run. We're going to see EDX and EAX change. Okay, so here we go. This is our number. All right, so let me go to show you what this is. Okay, timestamp counter is a 64-bit register present on all x86 processors. All right, now let me talk about this really quickly. So RDTSC stores into here. Let me bring up Notepad. I just want to show you, I just want to drill this point home. EDX, EAX, EDX, EAX. Okay, let's go looking here. Can I just like copy this or anything? I cannot. So here we see EDX has this value. Let's see, 0004A834. And we see EAX has this value, F531FD4A. Okay, EDX, EAX, what that's going to look like is EDX, EAX. Boom. That's the value. Okay, so EDX equals most significant 4 bytes, which means they're going to go first. Most significant first, least significant last. Okay, now if you're looking at this and you don't quite understand it, and you might think, well, then it says EDX EAX, so why can't I just do like this? You're going to end up with a totally different value. You're going to end up with this. Totally different numbers, completely different numbers. You know, with a quad word, 64-bit value, this is going to be a negative number. So we'll copy this, we'll go calc. Okay, let's click on hex. We're set to keyword, we're going to paste. And we see here that decimal, see that this is a negative number. And that's because, I mean, the more you get into this, you'll learn, like 7, so with a Q word, that's going to be, let's see, so 7, F, FF, FF, FF. Okay, that's 32 bits. We need 32 more bits, so FF, 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 FF. Let's see, 1, 2, 3, 4. Okay, that's the highest positive number that we can have on 64 bits. In hexadecimal here. Okay, so moving up from this would be 8 and all zeros. What happens when we do that? 8, or let's clear 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's see, 1, 4, 8, 12, 13, 14, 15, 16. Yeah, there we go. Okay, excuse me. So negative number there. All right. But this is the highest negative number, so it's kind of funky. You have to really get used to this if you're not yet. 7 and all F's is the highest positive. When you go up to 8 and all zeros, that's the highest negative. So the lowest negative number with 64 bits will be all F's. -1. All right, so anyway, the difference between this number and this number is drastic. So just be cognizant of that when you see these like combination register things, okay? So kind of derailed there, but that's okay. All right, so that's RDTSC, stores the value into there. All right, so we're interested in one of those two things with our IDIV here when we get to that. Okay, so first RDTSC, and you see that it saves the value in EDX EAX. Then we're going to XOR EDX EDX, which is going to clear EDX. And the reason we do that is because if the number that I generate from RDTSC, which is effectively kind of a random number, pseudo-random. Let me just make this discernment really quickly. Pseudo-random is good enough for our purposes. Pseudo-random is a number that appears to be random through the process that we used, but might not actually be random per the mathematical definition of random. Okay, so technically pseudo-random, but for our purposes random enough. All right, so RDTSC, we're generating a number. We're clearing EDX because we know that EDX EAX is going to be the full range of our number. So let me go into calc. All right, and the difference between EDX EAX being all zeros and then EAX. So let's say we generated FF, I can't do all the zeros, FF, 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 FF. Pretend that there are 8 zeros in front of here. We still have that full range, that those other bytes that we could be using for 64-bit, okay? Those are all zeros. Because of that, the highest thing that we're going to be using in our division is just EAX, which would be this much out of 64 bits. Okay, so it's a positive number. By XORing EDX, we take the potential range out of this which would be negative, and we place it into what will only be a positive range. That's the first thing. That's one thing that we do. So you're probably like, why? I don't even understand what's going on right now. Why the hell are you even doing that? IDiv divides what you specify. So here, ECX, which we know has our 3800 in it, okay? IDiv divides EDX, EAX by what you specify. So RDTSC stores the value we're interested in those two registers. IDiv divides something. And remember, EDX is the most significant, so that number would always come first in the division. So we want to get rid of that negative range. That's why I do that. Let's get rid of the negative range, so I XOR that. Then I shift the bits in EAX right by 1 to just add to the randomness factor. All right, so we see that here, you know, we haven't, this instruction has not executed yet. So if we go in our calculator here and we say F531 FD4A, there we go, FD4A. We take that, okay. After we shift right 1, we end up with that number. So what you can do is go RSH, or right shift, SHR, shift right, right shift. There's also left shift, or SHL. Right shift by 1 equals 7A98C here. Now, what's happening there? Okay, shift right works at the bit level. So you click this here. I'm on Windows 10, by the way. We see each bit. So we can see how a nibble is affected, right? Or an entire byte. All right. So what happens whenever you're doing is shift right by whatever number you specify. This could be 2, 3, 4, 5, whatever we want here. We're saying whatever's in EAX, which at this point, this is in EAX. Okay. So if we go back to here, I don't remember how to undo, so let's just go F531 FD4A. Okay, so we can see the binary here, right? So when you're shifting right, you're gonna, whatever the last bit is, you're gonna drop it off. It's not there anymore. And whatever's to the left of it will shift right 1. We're shifting right by 1. So just imagine you take this whole number, everything here, and this number falls off. This number goes here. This one goes here. This one goes here. This one goes here. This one here. This one here. And so on and so forth. Each bit shifts right by 1 position. Okay? If I had SHR EAX2, then this bit would fall off, and this bit would end up falling off because this one is gone. This one shifts 2, 1 off. This one would shift 2 to here. This one would shift 2, 1, 2. So you see, that's how shift right works. It works at the bit level. So if we go hex right shift by 1 equals, and we see how it shifted. Okay, so that's how that works. Okay, so now we get to our IDiv, and we have our random number here. Okay, IDiv, let's go into here. IDiv divides the contents of the 64-bit integer EDX EAX, okay, by whatever you specify, your operand. The quotient result of the division is stored in EAX, while the remainder is placed in EDX. Okay, we're not interested in the quotient because the result of the division that we're going to be doing, that number could be a whole lot higher. Okay, while the remainder of whatever we divide will not extend beyond the highest number that we provide, which is what we have in ECX, this 3800. Okay, so just remember the remainder of this division is going to be stored in EDX. Okay, so because of that, IDiv EDX EAX is divided by ECX, and we know that this is an ECX. So because we have nothing in EDX, we're going to be seeing in EDX, remember it said the remainder is stored in EDX. EAX is going to change to the result of the division of this divided by this. That will be the result of the division here. The remainder of it will be here in EDX. So let's go down to this instruction. Okay, so this is the result of the division. This is the remainder. Quotient here, remainder here. All right, this number, this EDX, is what we're going to be moving into that offset here. See how I'm moving EDX into here? This is the number that I'm moving into there. Right? Now here's the problem. 7DD, what is that? Let's go hex 7DD. All right, that's deck 2013. That's item number 2013. Okay, that's what's in that enemy. Well, I killed him, so I can't get it right now. But if I had captured him with the bug net instead, now bear in mind, each time you hit an enemy, this is going to execute this whole thing. So this number will change every time you strike an enemy. Okay, so once you capture that enemy, that's when you'll get whatever's here. All right, so we've got that. Now the problem is this, okay? When you want to see the remainder of something, you do modulus instead of divide, okay? So here's the issue that we're going to run into for this cheat, you know, that will make it imperfect until we do one more thing. 3800 divided by 3800 is what? 1. That's the quotient. That's 1. Okay? What is the remainder of that? 0. We're taking the remainder and we're using that. We're not using the quotient for what we're doing. Ergo, if somehow we end up with this process, it turns out that 3800 is our number, and then that gets IDiv, right, by 3800. Our remainder is going to be 0. 3800 modulus, which is going to show us the remainder of a division, 3800, is 0. Well, we know 0 is not an item, so we wouldn't get an item in that case. So that's an issue. The next thing is this. Let's say the number that comes through is 3799. The remainder of 3799 modulus 3800 is 3799. Okay? So if the highest number we can get is 3799 with what we're doing, then we can't even get the highest number item in the game. So 3799, right, modulus 3800 is that. 3800 modulus 3800 has a remainder of 0. 3801 modulus 3800 has a remainder of 1. So we have established that our effective range here is 0 to 3799. And you know, these numbers grow. So what is this? Hex 7A 98 7A 98 F E A 5. All right, so we're going to have that, and then we're going to modulus 3800. So our remainder is 2013. So no matter how high you go with these numbers, right, we're not ever going to get beyond 0 to 3799, no matter how high we go with our range of division. Okay, So because of that, I increment EDX. Inc means add 1 to. So because we're using EDX, after the inc, boom, it goes up 1. That suddenly shifts us from the range of 0 to 3799 to 1 to 3800. So we're going to get an item from within the full extent of the range of items. Okay. Then after that, see there's that IDIV, there's the inc. Then we jump back to return address. And in this case, the return address is to this instruction. ESI, right, sub, well, let's see here. No, it's this one here, I'm sorry. Move into this offset. And then we pop EDX, pop ECX, pop EDX, which restores everything back. And then we run our original instruction sub. And then we're going to jump back to the original place where we made our jump for our code injection. Okay? Now, here's the thing. So we've seen it work here. This is it. We've ascertained that this works, and we can see exactly what's going on in all these registers. Now with the worm enemies, there was an issue I ran into initially, and that is, look at this instruction here. That's the instruction that moves our value for our item ID into that catch item offset. The problem is that we're using EDX because the value of the remainder of the division automatically stores in EDX. If that is the value sitting in EDX and we want to move that value into EDX plus 140, at this instruction, EDX is going to contain our item number. It's not going to contain whatever the address is from here. Right? So I've done this. We jumped a random number. Okay? And instead of coming back to here and just immediately writing, we have to move what we have in EDX over into another register. I'm going to use EAX in this case. Then we have to pop EDX so that we get what was in EDX when we started this whole thing, right? Which, as it turns out, is this address. We want to restore that so that then we can move, or we can move from EAX into EDX plus that offset. All right, then I restore these other two registers, and then the original sub instruction. All right, so that's that. I don't know if I said it before, but this is not the most optimal way to do this. I think I did cover that before, so I'm not really going to dive into it again. But basically, by doing something like this, you're running certain instructions unnecessarily, when I could just have this run in line with each of these things. All right, but anyway, the last thing that I want to cover is right here where you see that I've done the same thing here and here. The only exception is I have an offset of 10 here and I have an offset of 13 here. Why aren't those the same? And put simply, I'm going to show you why. So here we have non-worm enemy, which is this one. Okay. Now, from this push instruction right here down to this jump, push down to the jump. Okay. You can count the bytes. So you have the instruction and its byte representation over here. Well, if we count all these bytes, okay, we're going to get hex 10. And I explained the intention of doing this to get the return address. However, the reason why I've selected these certain offsets is because at this jump here, the way it's represented by bytes is EBB0. That's how this jump to random number generator is represented in bytes. This one, the same instruction, because it's in a different place in memory and the way that a jump instruction assembles into its byte form, so worm enemy here, this was the worm enemy, the jump here, look how that one assembles. We've got these 3 extra bytes, these FF. And now you can't just go up here to this one and be like, all right, well, I'll just append FF onto there. It doesn't work like that. So if you try to provision for, you know, the specific number of bytes, it might not necessarily work. You might have to actually enable your script. And you could try something like this, online assembler disassembler. Now I've copied over something from here into here. Okay, and if you use something like this, sometimes you have to change a couple things. Like I have to add 0x for some offsets and stuff like that. And any labels, you want to put brackets around it to represent a memory address. Okay, now I'm going to say assemble. Now here I can see the bytes for each of these things. However, like how in your scripts, you can't, in an AOB, reference a dynamic memory address, because then your AOB won't work, right? With something like this, you can't reference a jump out of context, because it's not going to give you the appropriate byte value. Okay, so that's one thing to be aware of. All right. I think that's about it. The last thing I want to cover is that I also did this, close this, close that, go back. Okay, so I did a list of results. So from the game, I captured like 22, I think this is 22 enemies, and whatever the item ID was, or, you know, I get the item, then I went and referenced from that chart which ID it was. I wrote all those down here, or pasted them rather. Then I went to this online number generator, random number generator, and it said, how many items do you want? Let's say 22. I want to compare like my results from what I cooked up there in assembly to something like this. So between 0 and let's say 37.99, and we'll just pretend 0 is 1, and then we can go up to 3,800, right? So I'll submit query here, and then I took whatever list generated from here, look, leet. And let's close that. Where's my notepad? Bam. And I compared it to these to see, like, what does the general range look like that was generated? And it does seem random enough. So, good enough. Job well done, right? Compensated for having a faulty range in there initially. Learned about RDTSC. We're looking at stuff at the bit level, right? Refactoring your code. Now, if you could do like global alloc. So if I wanted to reference stuff outside of this script, like let's say I enabled the script, and then I have another script that I want to reference something from this one, I could do like global allocs for stuff like that. But anyway, that's pretty much it. I hope you enjoyed this. I have no idea how long I've been recording for, but like I said, I just wanted to do more of like a lecture format, as if you were sitting here with me and I'm trying to explain things there. So, yeah, if this stuff was way above your head, definitely go check out my other cheat engine videos. There's something for everyone there. If you like me doing stuff like this, let me know. If you have some questions based on stuff in this video, go ahead and let me know as well. And I may or may not get around to helping, depending on what the question is. If it's something I've addressed before, then maybe I'll just point you to a different video or whatever. So anyway, I really appreciate you watching, and any feedback you want to provide. Give me a thumbs up if you enjoyed it. Don't forget to subscribe if you're not subscribed yet. And I'll just see you on the next video. All right? Take care.